Okay, so what we know, so in the from the previous classes, what we uh, gained that there are different models of automata. One is like finite state automaton, finite state, and then this is a particular model, and you know that particular model accepts this particular model, accepts the languages. That means that is called regular languages, and this particular regular language, that is generated by grammar, that is called regular grammar. That means this regular grammar, that will generate regular language, and this regular language is accepted by these machines. The same as that. That means this regular grammar, that generates this particular language, and this regular language is accepted by a machine. This is accepted by a machine, that is known as finite automata. And we also studied, this is a concept, that is a context free grammar. Context free grammar, and this particular grammar, generates language, that is called, context free language. And this particular context free language, that is accepted by a machine, right? And this particular machine is known as push down automata. So that means what I'm saying, this context free grammar that generates context free language, we already covered this context free machine and context free language and context free grammar. Now we discuss this context free language is accepted by a machine. This particular machine is known as push down automata. Now the thing is, that there is lots of regular languages. That means, we can write a b star, that is a type of language that is called regular, and this is a, regular languages. And context free languages is like that: a to the power n, b to the power n is greater than equals to 1 or 0, whatever be the thing. And what we understand, that this particular, this language, that is not accepted by this finite state automata. Why? Because you don't know the value of n, because n is not finite, right? Since n is not finite, then you cannot, you cannot find this. That means you cannot, you know accept this particular language by finite state automata. So the thing is that, that means to accept this type of language, we need a memory, right? We need a memory. And so you can say that finite automata, and if we add a memory, right? If we add some memory, we can build push down automata. That is called, that means finite automata is a machine that we understand clearly, and if we add some memory, then we will get PDA, right? Now the concept is that what type of memory we can add, right? You can think that we can add, array, we can add a linked list, we can add, this type of data structures you can add here. Otherwise you can add queue or stack, whatever be the thing. But the thing is that whenever you have to add array or linked list, whatever be the thing, there is some elements are given, and you have to insert a particular element in a particular location, and that type of headaches are there. And in case of queue also, that there should be two pointers, like, the front and the rear, and by using front and rear you have to insert something that will also, that creates a problem. So it is better that we can use a memory where the insertions and deletions can be done by using only pointer. That means whatever you can insert, that should be inserted through, by using top, and whatever you are deleting, that means pop, that is also done with the pointer top. And you are not, we don't have to think about that. That means when you are inserting something, it automatically inserted in that following manner. You don't need to trace out like that. So that's why we are introducing the memory as a stack. That means if this is a finite automata and if there is a stack, this is nothing but, PDA. It's nothing but that. That means a finite automata and a stack, that will create the thing that is nothing but a machine that is called push down automata, which can accept this type of language. That particular language is known as context free language, and we know about the context free language, and we also know about the context free grammar. So the thing is that in that particular case, what we can say about that the thing is that, so it's nothing but a finite automata. So if we draw a just a diagram for that, that means I want to draw a basic diagram, then what we can say about that, that means this is the corresponding input tape. If there is the alphabets, say the alphabets are, say, X, Y, Z, so this is the alphabets, that means this is the input tape. We know about the finite automata, that means there is a finite control unit, say this is the finite, control unit. And what we know, that this finite control unit will read input, this is the read header, that means there are some header which can read this particular input. And depending on the rule, that means if this is in state q0, we are getting this input X, then we are moving to q1 state and its head will be pointing to the next locations, like that. This is the simple finite automata. Now what we have to introduce, I just introduce a concept of stack. Say this is the, stack symbol, this is the, I have introduced a memory which is called stack, and this is the, topmost, you can say topmost stack. What is the meaning of that? That means whenever we reach that particular symbols, then we can say that the stack is empty, no other symbols are there. That means this is the inbuilt symbol that is within the stack, we already push it. That means, for stack we have two operations, one is push, and if we want to delete something, we are popping. That means whatever weather, that means in that particular PDA, if this structure, this whole structure is nothing but the structure of push down automata. Okay. Now the thing is that means what will happen in that particular case, a finite control that will read an input, and as well as it will see the stack content, and by seeing this input symbol as well as the stack content, it will decide the next step. So in case of, finite state automata, what will happen, this is the q0, this is the input symbols, and depending on this two, we are deciding the next move. But in that particular case of PDA, not only we are just seeing the input tape, we also have to see the, stack content. And after seeing this input tape content and the stack content, we are deciding what we have to do. That is the difference. That means when you are declaring, say, finite state automata, whether it is a deterministic or non-deterministic, the tuple is nothing but, set of steps, input symbols, transition functions, and what we will get, that is the set of state, that is the input state, that is the, transition functions, and there is a set of inputs, right? And that inputs is written, this is the input alphabet, and there are set of final state. So this is nothing but we are representing the this finite state automata by using this 5 tuple, and depending on the transitions rule, we are determining that whether it is a deterministic finite state automata or it is a non-deterministic finite state automata. So the next is that so in that particular case, that means what we are getting, that means here a new thing that is introduced, that is a stack, that is a memory. And why it is stack, I am explaining that because stack we are not bothered about with what position we have to insert and what positions we have to delete, so why should we take array or something other else? So that's why we are using stack. So this finite automata with the property of the stack, that will give you the push down automata. And already we know that context free grammar, that is generating the context free language like a to the power n and b to the power n, where n is greater than equals to 1 or 0, and that particular context free language is accepted by a machine, that is push down automata. So now if we can write, if we can let's see an example. That means, say the language is a to the power n, b to the power n, and we already know that this particular language is not accepted by finite state automata, because n is countable infinite and you have a finite memories to store the number of elements. So that cannot be done by using finite state automata, whether this is a deterministic or this is a non-deterministic. So in case of push down automata, first know the concept, right? If you know the concept, the mathematicals and all the push down is not too hard. So if we have a stack, how can we accept this? তার মানে আমার কাছে একটা স্ট্যাক থাকলে আমি কি করে এই জিনিসটাকে সিম্পলি অ্যাকসেপ্ট করব? তুমি ভেবে দেখো, একটা মেমোরি থাকলে কি সুবিধা, আমার যতখানি এ আসুক আমি পাতি কথা সেটাকে কি করছি, স্ট্যাকে পুশ করব, রাইট? এবং স্ট্যাক কন্টেন্টে কি আছে, z0 আছে ধরে নিচ্ছি, দিস ইজ দ্য করসপন্ডিং স্ট্যাক। তার মানে আমার ধর একটা ইনপুট এলো, ইনপুট আই ডোন্ট নো, ইনপুট ইজ লাইক দ্যাট a say b b b b b, and input should be ended with some characters such that we know that input is ended. So whenever যতক্ষণ a আসবে আমি কি করব, স্ট্যাকে পুশ করতে যাব, আমি কিছু ভাববো না, যতক্ষণ a আসবে a তার মানে উই আর পুশিং ইনটু দ্য স্ট্যাক, রাইট? আমি জাস্ট স্ট্যাকের মধ্যে পুশ করব। তাহলে যদি তুমি ধরো একটা ফাইনাইট স্টেট অটোমেটার মতোই ভাবো, আমি একটা Q0 স্টেটে আছি, রাইট? উই আর ইন Q0 স্টেট, দিস ইজ দ্য ইনিশিয়াল স্টেট। তাহলে দেখো প্রথমে ইনিশিয়ালি স্ট্যাক কন্টেন্ট যদি Z0 থাকে, তার মানে আমি কিভাবে লিখছি, এ হচ্ছে ইনপুট যেটা আমি রিড করছি, রাইট? দিস ইজ দ্য ইনপুট অ্যান্ড দ্য স্ট্যাক কন্টেন্ট, বিকজ ডিপেন্ডিং আমি কি বললাম, স্ট্যাক কন্টেন্ট টপ অফ দ্য স্ট্যাক, আমি ধরো এইগুলো নেই, রাইট? Initially these A's are not there, right? So what I am saying, that in that particular case the stack content, that is nothing but a, আমি হচ্ছে ইনপুট সিম্বলটা a রিড করলো এবং স্ট্যাক কন্টেন্ট z0 আছে। then what we have to do, আমি কি বলেছি, a যতক্ষণ আসবে you just push the value of a. now the stack content that should be a and z0, right? The stack content is a z0, that is nothing but the input, and that is nothing but the stack, top of the stack, right? This is the top of the stack, top of stack, and you are doing like that, you are pushing a. So that's why আমি প্রথম দুটো symbols লিখছি, that is a z0, right? now what will happen, then আবার যদি a আসে, then কি করব, আমি কি বলেছি, যতক্ষণ পর্যন্ত a আসবে ততক্ষণ পর্যন্ত আমরা পুশ করব। তার মানে যদি আবার এ আসে তাহলে আবার আমি স্ট্যাকে পুশ করব, তাহলে আমার তো অন্য স্টেটে যাওয়ার মানে নেই। তার মানে আমি যদি এ পাচ্ছি ইনপুট, মানে মুভ করছি, এবং আমি যদি আবার এ স্ট্যাক টপে থাকে তাহলে আমি সেটাকে পুশ করব, তার মানে স্ট্যাক টপের প্রথম দুটো কি হয়ে যাবে, এ হয়ে যাবে, রাইট? তার মানে এই এই জিনিসটা দিলে যতবার এ হোক না কেন ও প্রত্যেকবার এটাকে পুশ করবে। এখানে আমার 5 বার এ আছে, দ্যাটস ওয়াই 5 টাইমস ও পুশ করবে। আই এম নট বদার অ্যাবাউট হাউ মাচ time a is there. Whenever a is there, I have to push it into memory, right? Now whenever b is there, আমি কি বলেছি, পপ করব। আমি যখন b পাবো তখন পপ করব। তাহলে পপ করা মানে এটাকে এপসাইলন দিয়ে লেখা। আমরা লিখি কিভাবে পপ করা মানে, তার মানে আমি নতুন স্টেটে যাব কখন, যদি ইনপুটে বি হয়, আমি ইনপুটে এখানে বিতে এনেছি and we are getting b and the stack top is a, then we are popping this. তার মানে popping means is nothing but epsilon, right? We are popping it, that means epsilon, that means we are popping it and it we are going to the new state and in the new state যত খুশি a আসুক না কেন আমি শুধু পপই করব, রাইট? তার মানে যত খুশি a আসুক না কেন I am just popping the thing, we are popping the thing and পপ করতে 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 আমি কি দেখলাম, এখানে 5টা বি 1 2 3 4 5 and we are reaching to the input is epsilon, epsilon লাস্টে থাকবে। তার মানে epsilon, what do you mean by epsilon? Epsilon means there is no input remaining, right? No input is there. So the thing is that when this is a BA, you can write like, it will be better if we follow the same notations. That means this is a not this, I can write like that. That means whenever this is a B and stack top is A, this is the epsilon, that means we are popping the content. And after popping and popping, what we will reach, and if we will get that this is the epsilon and the stack content is Z0, then it remains Z0 and we are reaching the, that means আমার ইনপুট শেষ হয়ে গেছে এবং তার সাথে সাথে স্ট্যাকের কন্টেন্টও Z0 হয়ে গেছে। তার মানে আমি বুঝবো যতগুলো নাম্বার অফ A পড়েছিল ঠিক ততগুলো নাম্বার অফ B পড়েছে and the particular string is accepted, right? এবং তুমি যদি এইটাকে রুলের মাধ্যমে লিখতে চাও, দ্যাটস এ ট্রানজিশনস রুল, তার মানে আমি কি লিখতে পারি, এটা ডেল, এটা Q0, আমি ইনিশিয়াল স্টেটে ছিলাম, এখানে দেখো আমি A পড়েছে, A is the input, mind that A is the input and as well as I have to see the stack top, this is the top of the stack, top of stack, then what will happen, this is nothing but I am pushing the value, that means stack content AZ0, প্রথম দুটো আমরা লিখি, দেন আমি Q0 তে আছি, ইনপুট A এবং স্ট্যাক টপ ও A, তার মানে আমি সেটাকে পুশ করব, রাইট? এবং আমি কতক্ষণ পুশ করব, যতক্ষণ না বি পাই, তার মানে যখন বি পাবো এবং স্ট্যাক টপে কি আছে, এ আছে, তার মানে আমি Q1 এ যাব এবং পপ করব, পপ মানে এপসাইলন। সিমিলারলি আমি যত খুশি ধরো Q1 স্টেটে থাকবো এবং আমি যদি একই জিনিসই পাই তাহলে আমি পপ করাই যাব, পপ করব কতক্ষণ পর্যন্ত, যদি দেখি আমি Q1 স্টেটে আছি এবং কোনো ইনপুট নেই এবং স্ট্যাক টপটা Z0 হয়ে গেছে, তাহলে আমি বুঝবো ফাইনাল স্টেটে এবং সেটা Z0টা Z0ই থাকবে, আমি কিছু কন্টেন্ট চেঞ্জ করব না। That means this particular language is accepted. Now you can take any string, right? You can take say any string and say I am taking a string, that is this is the corresponding string, but that is not satisfying a to the power n, b to the power n and particular conditions, because there are 3 a's and 4 b's. Then what will happen, you just see that we are in Q0, right? We are in Q0, initial state should be started from that. We are getting A, right? We are getting A. If we are getting A and the stack top, and the stack top is Z0, then what will happen, I am just pushing the content in stack, that means A would be pushed in the stack and we are remains in the same state, right? We are remains in the same state. That means if this is A, this is a Z0, I am doing the same thing. Now what will happen, again the control is moved to the next one, that means we are reading A among stack content is also A, then what will happen, A will be again pushed. So if we are in Q0 state, stack content, we are reading input at A and the stack content is A, then AA will be there. Now again a will become, that means it will be pushed into the stack by using this, because if the input is a, we are pushing a into the stack. Now b will reaching. What do you mean by when the b is reaching? What I am saying, that means I am reaching b and the stack top is a. This is the stack top and stack top is a. We are popping it, right, and moves to the state q1. That means we are popping it and move with the state q1. Now again second b will come, and when the the second b will come, then what will happen in case of when the second b is come, what will happen? That means we are in state q1, right? That means this state we are in state q1, and input is b, and as well as the stack content is a, because you are popping this is the thing where we read. That means the stack content is a and we are again popping it. That means the thing will happen that this is b and this is a and we are popping it. So again that will be incremented, b is come again, that a. Now what will happen? You are in state q1, right? I am getting b, I am getting b, and the stack content is z0, right? But there is no such defined rule is there, right? Because just q1 ba, there is no such rule, right? That means when there is no defined rule, that means your program will halt, because there is no transitions rule is defined, right? In that particular case you need not to define all the transitions rule, because PDA is naturally deterministic, non-deterministic in nature. The PDA is generally it is a non-deterministic behavior, and we are making it deterministic. So in that particular case, what we will see, that if we are given some input rather than the form of a to the power n and b to the power n, what we will see that that particular input, for that particular input no transitions rules are defined. That means your program will not reach to the final state, right? Since it not reaches to the final state, that means that particular string is not accepted. So that is nothing but a PDA. That is nothing but a PDA. That means in input string we have to check the top of the stack, and depending on the top of the stack we are taking the decisions. So that means in that particular case, what the tuple that we can say about that, that means we need set of states, right? We need set of input, we need transitions rule, we need initial state, and extra thing that we need, this is the stack top symbol that is already been incorporated before starting of that, and set of final state, and this is nothing but the stack alphabet, right? Because the stack alphabet in some questions, in that particular questions we are inserting a and b, but in your questions it may be given when you will get a you are pushing p in the stack. If this is given, then you have to push p in the stack. Whenever you get a, you are pushing p into the stack. So that means you have to introduce another thing that is called this big tau, that is called stack alphabets. So what we can say, this is the corresponding, that means in case of finite automata the number of tuples is 5, but in case of push down automata we are introducing two extra string. One is z0, and on the stack alphabet there are 7 tuples. So what is this? This q is nothing but this is a finite set of states, the finite set of states. This is input symbols. This is input symbols. This delta I am writing this, thus this is the transitions functions, and this q0 is nothing but initial state. This is initial state. What is z0? This is nothing but bottom of the stack, bottom of the stack. And the thing is that if, what is this? This is nothing but set of final states. This is a set of final state, and this is nothing but stack alphabets. this is nothing but stack alphabet. So this is the corresponding symbol. And what I am saying that PDA is generally non-deterministic natures, right? We make it deterministic. That means PDA has like a finite automata. It has a two versions, right? Non-deterministic and deterministic. Specifically, in that case also, basically the PDA is non-deterministic. We are making it deterministic, right? That so this has, if we write deterministic PDA, and if we write non-deterministic PDA, the transition functions is defined like that. That means what is transition function? You are writing that we are in state something, we are getting an input, and we are pushing or popping. What we are pushing or popping? The stack alphabets, right? So the transition function, that means this is a Q, this is the Cartesian product. Why? We already know in case of finite automata, this is just input symbols, either epsilon, because it may be epsilons if you are popping, and as well as there is stack content. This is the stack content, right? What is it? This is the number of states. This is the states, this is the input symbols, it may be epsilon, that's why I am writing epsilon, and one is the stack content and the stack content. So I am writing with this Q cross input symbols cross this, and in case of deterministic Q cross, because you are changing, this is the stack content, you are changing the the stack itself. So that's why I have to write Q cross this stack. In that particular, when we are dealing with the finite automata, we are just writing the number of states because you are changing the states. But in that particular case, as well as you are changing the state, as well as you changing the content of the stack. So that's why I have to also write this content of the stack. And in case of non-deterministic, that is a 2 to the power. That means if we write this non-deterministic, this is same. That means this is a set of states. This is the input symbol. We can do it epsilon. So that's why I am writing union epsilon. This is the content of the stack, and this is nothing but 2 to the power Q cross this is the corresponding thing, right? So 2 to the power this, that means this is nothing but non-determinism nature, right? So the thing is that there is also another thing that you need to know. That means this PDA, this PDA, that means in case of when we are dealing with finite automata, we know after consumption of the whole strings, if the automaton reaches to the final state, then the string is accepted, right? But in case of PDA, what we see here, that when we after consumption of the whole string, if the stack contain that is Z0 and the it will reaches to the final state, then we will get that the string is active. It may be possible that we are reaching to the final state, but the stack content is not Z0. That is also accepted. So by using stack or by using final state, that means the PDA you can design with respect to final state, or you can design with empty stack. That means the PDA can be accepted if the stack is empty. That means the stack content is Z0. Otherwise your PDA will be accepted when we are reaching the final state. I am seeing what is the difference. And whether you write the PDA by using final state, or whenever you write a PDA with the empty stack, that both has the same power. That means there is no changes of the accepting power of the PDA. That means these both have same power. These both have same power. So the thing is that in the previous case, what we will see, you just see that we are trying to accept this language, which is a to the power n, b to the power n, where n is greater than equals to 1. And for that purpose, we are using a stack. Initially, the stack contain, bottom of the stack contains Z0, and whenever a comes, I am pushing the value of a. যখন b এলো, আমি কি করলাম, ধরলাম আমি একটা স্ট্রিং দিয়েছে, একটা পার্টিকুলার ল্যাঙ্গুয়েজের মধ্যে একটা স্ট্রিং, ধরো সেই স্ট্রিংটা হচ্ছে a a a a b b b b, রাইট? সো আমরা কি করলাম, এ যখনই এলো পুশ করলাম এবং বি এলো পপ করলাম এবং স্ট্যাক কন্টেন্ট z0 পেলাম এবং সেটাকে সুন্দরভাবে লিখেছিলাম কিভাবে, আমি হচ্ছে স্টেট কিউ নটে আছি, আই এম গেটিং ইনপুট এ, স্ট্যাক কন্টেন্ট যদি z0 থাকে আমি পুশ করছি তাই জন্য হচ্ছে a z0 হচ্ছে, অ্যান্ড এ ইনপুট নিচ্ছি যদি স্ট্যাক কন্টেন্ট এ থাকে, মানে ইন দ্য সেকেন্ড কেস, মানে এটা পুশ করার পর তো পরে স্ট্যাক টপ অফ দ্য স্ট্যাক এ থাকছে, তাহলে এ থাকলে আমি এ পুশ করে দিচ্ছি। অ্যান্ড কতক্ষণ ধরে পুশ করবো, এই ঘুরেই যাবে। ফার্স্ট আমরা বি পেলে, আমি স্ট্যাক কন্টেন্ট যদি এ থাকে মানে আমি বি পেলাম প্রথম, এই বিটা পেলাম অ্যান্ড স্ট্যাক কন্টেন্ট এ আছে, তাহলে আমি কি বললাম, পুশ করতে, পপ করতে। পপ করা মানে আমি জাস্ট রাইট এপসাইলন, রাইট, উই আর পপিং দিস অ্যান্ড উই আর রিচিং টু অ্যানাদার স্টেট দ্যাট ইজ q1, অ্যান্ড আমি যদি বি পাই এবং অলরেডি আমার স্ট্যাকের মধ্যে এ থাকে টপ অফ দ্য স্ট্যাক, তাহলে আমি পপ করে দিচ্ছি, রাইট। অ্যান্ড ইট মে বি পসিবল, আমি লিখলাম কি রকম ভাবে, যে ইফ ইনপুট শেষ হয়ে গেছে, ইনপুট সেট মানে আমি এপসাইলন পেয়েছি, ইনপুট ইজ অলরেডি কনজাম্পশনস and the stack top is z0, if I am reaching this state where the stack top is z0, it remains in z0 and that particular thing is accepted by this, right, and this is nothing but acceptance by final state, this is nothing but acceptance by final state, তার মানে ফাইনাল স্টেট দিয়ে আমি অ্যাকসেপ্ট করেছি। এখন the thing is that if we draw the same diagram when the acceptance by empty stack, what does it mean, তার মানে আমি এই ফাইনাল স্টেট এই কনসেপ্টটা আঁকবো না, that means I am not writing this thing, but we are writing that it may be the possible, that means what I am writing here, that means if the input its consumption is done, if the stack top is z0, I am empty this stack, right, input consumption is already done, the stack content is z0, the bottom of the stack, then we are emptying the stack, that is nothing but that is nothing but acceptance by empty stack, this is nothing but, that means we can write this, and this is nothing but acceptance by empty stack, this is nothing but acceptance by empty stack. The same is that this is, there is no concept of final state and here the concept of empty stack, both have the same power, that means if you can draw a PDA by acceptance by final state, you can draw the PDA by using acceptance by empty stack, and you don't get any such language which is accepted by PDA acceptance by final state that is not accepted by the empty stack, that is not possible, that means every language which is accepted by PDA by using final state, that should be accepted by PDA when we are using empty stack, that is not, both have the same power, both have the same power. So I think this basic thing, this is the basic thing that is clearly understandable, I think so. So if we go to some
স্যার বলছি এখানে এ এ এ মানে আমরা কেন, মানে যখন আমরা এ এক্সেপ্ট করছি ঠিক আছে, তাহলে আমরা ওই সেম স্টেটে কেন আছি, মানে আমরা তো Q1 এ মুভ করে যেতে পারি।
তো Q1 এ মুভ করবো কেন বলো তুমি, Q1 এ মুভ করবো কেন, আমি স্টেম স্টেটে থাকলে অসুবিধাটা কি?
স্যার কিন্তু মানে ওইটা যদি এ জেড জিরো আছে ঠিক আছে, মানে ফার্স্টে এইটা নিল, দিয়ে যখন সেকেন্ড এটা এলো ঠিক আছে, মানে ও কি বুঝতে পারবে মানে যে কোনটা ইউজ করতে হবে, মানে
কেন বুঝতে পারবে না, এটা তো নন ডিটারমিনিস্টিক নেচার নয়, তুমি যখন বলছো ইনিশিয়ালি আমার z0 ছিল, রাইট, আমি একটা স্টেট Q0 এ আছি, আমার ইনপুট এলো এ, আমার স্ট্যাক টপ দেখলাম z0, আমি স্ট্যাকের মধ্যে পুশ করে দিলাম, রাইট, তার মানে এখন স্ট্যাকে এ চলে এলো, রাইট, এরপর যখন আরেকটা ইনপুট আসবে তখন তো স্ট্যাক টপটা আর z0 নেই, স্ট্যাক টপটা এ হয়ে গেছে, রাইট, তখন তো স্ট্যাক টপটা এ হয়ে গেছে, তখন আমি পুশ করবো আবার এ কে, তো আমার অন্য স্টেটে তো যাওয়ার দরকার নেই, এখানে তো আমার নন ডিটারমিনিজম নেই, দিস ইজ এ ডিটারমিনিস্টিক, রাইট, বিকজ ও কনফিউজড হওয়ার তো ব্যাপার নেই, তার কারণ স্ট্যাক টপটা তো অলরেডি ডিটারমাইন করে দিচ্ছে, রাইট।
Yes, sir.
আচ্ছা, যদি এটা বুঝে থাকো তাহলে ধরো আমাকে পিডিএ ডিজাইন করতে দেবে তোমাদের, হয়তো যদি দেয়, আমাকে দিল রাইট দ্যাট a to the power n, b to the power m, c to the power n, where n m is greater than equals to 1, right? So if we can design, that means what we have to compare, that means a এর সাথে আমায় c কে compare করতে হবে, right? So in that particular case, what we can say about that, that means আমি তো এরকম ভাবে ভাবতে পারি, স্ট্যাক টপে আমার z0 আছে, যখন a এলো I am pushing this, right? But when b comes, I am not doing nothing, right? I am doing nothing. But b, I need not to count number of b's, right? Because that is not dependent. So we are not manipulating anything in the stack. If this is the stack top is a, we are replacing it by a. That means if b will come, if the stack top is a, that remains a, we are not pushing anything, right? And when the c is come, you are just popping it until and unless you are getting z0, right? That is the concept. That means by seeing the language how you can implement in stack, that is clearly understandable. Then you can draw the diagram. It's not too hard. We are in state q1, right? What will happen, what I am saying, that when there is a and the stack top is z0, we are pushing it, right? And whenever this a is again coming, that means if the a is coming and the stack top is a, we are again pushing this. There is no problem. How much time we will push? Until and unless b will come. When b will come, I am going to another state, but I am not doing nothing within a stack. That means if this is a, that will be a, and we are in state q2, and that will be in state q2 যতক্ষণ পর্যন্ত b টা থাকছে। and b থাকলে আমি একই কাজ করছি, যে যদি b আমি ইনপুটে থাকে, a যদি স্ট্যাক টপে থাকে, তাহলে আমি এই রেখে দিচ্ছি। এটা কতক্ষণ পর্যন্ত চলবে? c আসা পর্যন্ত। c যদি আসে, তাহলে আমি কি বলেছি, যদি স্ট্যাক টপ a থাকে তাহলে আমি কি করব, সেটাকে পপ করে দেবো, এবং দ্যাট উইল কন্টিনিউড। আমি হচ্ছে q3 স্টেটে গেলাম, এবং এটা কন্টিনিউ করবে যতক্ষণ না ইনপুটটা এমটি হয়। তার মানে আমি এটাকে স্ট্যাকটাকে বারবার পপ করছি। পপ করতে করতে যদি দেখি আমার এপসাইলন, তার মানে আমার কোনো ইনপুটে কিছু নেই, এবং স্ট্যাক টপে z0 আছে, তাহলে আমি z0 রেখে দেব, এবং I am accepting the state, right? That's all. তার মানে আমি কিন্তু এই পার্টিকুলার ল্যাঙ্গুয়েজটাকে অ্যাকসেপ্ট করে নিতে পারছি। দেখো ব্যাপারটা বুঝলে কি বুঝলে না? ইফ ইউ হ্যাভ এনি কনফিউশন, তুমি আমায় বলো, যে যদি কিছু কনফিউশন থাকে, বিকজ দ্যাট ইজ দ্য ইম্পর্টেন্ট থিং টু নো, যে আমরা কিভাবে করব ইমপ্লিমেন্টেশনটা।
যখন বি আসছে মানে তখন আমরা স্কিপ করছি, মানে দিয়ে তারপরে যখন সি এলো মানে ওই এ গুলো যেগুলো আছে সেগুলোকে পপ করছি, তো
একদম
এটাই।
একদম, দ্যাটস অল।
আচ্ছা,
ওকে, যদি হয়, আশা করি তাহলে যদি বুঝতে পারো, তাহলে আমায় এক্ষুনি ইমপ্লিমেন্টেশন তোমরা খাতায় করে আমায় বলো, যে যে আমি যদি বলি যে ইউ হ্যাভ টু ইমপ্লিমেন্ট দিস a m n and b to the power n, c to the power n, and this is mn is greater than equals to 1. Take 2 minutes or 3 minutes and tell me the design. আমি ডিজাইনটা আঁকবো। Particular case, that this is the m plus n. That means what is the number of a's that is inserted? If we are copying this b and c, that should be same. তার মানে এখানে a যদি ইনসার্ট করি, ধরো লাইক দ্যাট, আমার তো ভাবার দরকার নেই, আমার a ধরো a ইনসার্ট করেছি। when we are getting b, we are just popping, and there is a z0. when there is a b, we are popping the thing, and when there is a c, again we are popping. If we get this z0, then it is accepted. That means the total number of m plus n, that should be same is equals to number of b plus number of c. So what Sandeep tries to say, that if this is the input q0 or q1, whatever be the state, If there is A and Z0 is the top of the content, stack content, we are pushing it, right? And when we are getting A and the top of the stack is also A, we are again pushing it. Now when we will get B and the stack content is A, we are popping it and we are going to another state and we are doing the same thing. That means whenever B is coming and the stack content is A, and that is we are popping it, and until and unless we are getting C, and when we are getting C and the stack content is also A, we are popping it, right? And that continues, because whenever C is coming and the stack content is A, we are popping it, and until and unless the input is empty, stack content is Z0, it remains Z0, and we are reaching the final state. So that is the nothing but the corresponding PDA. That is nothing but the corresponding PDA. So now if we write this one, if the PDA is like a to the power n, b to the power m plus n, c to the power m, then nm is greater than equals to 1, তাহলে এটা ড্র কি করে করবে বলো দেখি? Whether it can be accepted by PDA
স্যার
or not. বলো।
প্রথমে এ গুলো পুশ হবে,
আচ্ছা এইগুলো পুশ হলো,
তারপরে বি পপ করলো।
আচ্ছা বি তো বেশি
হ্যাঁ,
হতে
হ্যাঁ।
পারে, ধরো আমার দুটো এ এলো, তাহলে বি ধরো আমার এরকম হতে পারে 5টা বি আর সি হচ্ছে 3টে, রাইট?
হ্যাঁ হ্যাঁ, তো ঠিক আছে। তো প্রথমে বি পপ করলো, তো তো তারপরে যেই Z0 পৌঁছাবে তখন বি আবার পুশ করবে।
আচ্ছা ধরো Z0টা পৌঁছাবে কি করে? ধরো আমার, আচ্ছা তুমি বলছো এটা Z0 আছে, এ পেলাম, পুশ করলাম, এবারে বি পড়লে পপ পেলো, তাই তো? এটাও পপ করলো, এবারে
Z0 তো টপ হয়ে গেল, তো আবার বি গুলো পুশ করলো ওইখানে,
আবার Z0 এলে বি গুলোকে তুমি পুশ করবে, তাই তো?
হ্যাঁ, দিয়ে এবার সি আসছে, তো সেইগুলো আবার পপ করে দেবে, এইগুলো আবার পপ করবে।
তুমি বলছো যখন Z0 পৌঁছাবে তখন আমি আবার, তাহলে ওটাকে লিখবে কি করে?
আচ্ছা, সেটা
তাছাড়া তুমি আরেকভাবেও ভাবতে পারো, দ্যাট ইজ ট্রু, আমাকে শুধু লেখাটা দেখতে হবে যে when we are reaching Z0 again, তাহলে আমি যদি Z0টা রিচ করি তাহলে আবার পুশ করা শুরু করব, রাইট? So that may increase the number of states, right? And if you think like that, a to the power n, this is a b to the power n, m plus n, so আমি তো এইভাবেও লিখতে পারি, এটা যদি m plus n হয়, we can write like that m plus n, because m plus n and that both are same thing. So a to the power n, b to the power n, b to the power m, c to the power m. So if we can think like that, that means we are comparing these two things, that means a to the power n, b to the power n, and again we are comparing these two things, b to the power n, c to the power n. আমরা অলরেডি এই দুটো জানি, তাহলে আমি যদি এইভাবে কম্পেয়ার করি দেন উই ক্যান অ্যাকসেপ্ট লাইক দ্যাট, রাইট? তার মানে আমি এই ক্ষেত্রে কি বলছি, if this is input is a, stack of is a, I am pushing this. If the input is a, stack top is Z0, I am also pushing this. And whenever we reach B, we are popping, we are start popping, and in that particular state, if this is a B, this is an input, we are start popping. Now the thing is that in that particular case, if the input is B and this is a Z0, this is a B, Z0, that means we are popping. Whenever this is a your step like that, we can write like that. That means whenever we reach B, right, and we are getting A, we are popping it. And the thing is that whenever we reach this z0, রাইট? তার মানে পপ করতে করতে আমরা z0 তে রিচ করেছি, বাট স্টিল আমার কাছে ইনপুট b আছে। আমরা কি করলাম, পুশ করা শুরু করলাম, এবং এখানে b থাকলে we are pushing it, right? And the thing is that I can think like that if we break it, then the number of steps and as well as my illustrations will be easier, but the thing is same. That means আমরা z0 তে রিচ করে দেব, z0 তে যখনই রিচ করছি তখন আমি আবার পুশ করা শুরু করে দিচ্ছি, বিকজ উই আর কম্পেয়ারিং দিস b টু দি পাওয়ার m। তার মানে b টু দি পাওয়ার n যখন হবে উই আর গেটিং z0, and again we are pushing the same thing, right? And we are pushing the same thing and until and unless we are getting c. That means যখন আমি c পাবো এবং স্ট্যাক টপ যদি b হয় তাহলে আমি পপ করা শুরু করব, এবং we are doing the same thing, পপ করা শুরু করব, এবং তারপরে দেখব ইনপুটটা শেষ হয়ে গেছে, স্ট্যাক টপে z0 আছে, আমি z0 রেখে দেব, and we are reaching to the final state. So is it correct? বোঝা গেছে কি করলাম?
স্যার আমি তো এটাই বলেছিলাম।
ইয়েস, তুমি এটাই বলেছিলে। সো দ্য থিং ইজ দ্যাট আমরা জাস্ট যদি ভেঙে নিই তাহলে এটাই এইভাবেই করা যাবে। ভেরি গুড। দ্য থিং ইজ দ্যাট যদি আমার ল্যাঙ্গুয়েজটা এরকম হয়, দ্যাট মিনস a টু দি পাওয়ার n, b টু দি পাওয়ার m, c টু দি পাওয়ার n প্লাস m, nm is greater than 1, রাইট? তাহলে প্রসেসটা
তখন তো ফার্স্ট স্টেটেই মানে ওই বিএ, তারপরে বিএ হবে, তারপরে বিবি, মানে ফার্স্ট স্টেটেই আমি সবকটা এ এক্সেপ্ট করব, সবকটা বি এক্সেপ্ট করব, দিয়ে তারপরে সিটাকে আমি পপ করতে শুরু করব।
That is simple. That is same as the previous one. That means in that particular case, what will happen? That if we are in A, that is a Z0, this is a Z0, and the thing is that if A, this is A, we are pushing it. That means if we are getting B and the stack top is A, it may be possible the stack top will A, and we are pushing this particular thing. And if we are reaching B, we are reading B, and we are pushing like that. And the thing is that until and unless we are reaching C, getting B, and we are popping the content, the thing is that we are still continue popping, either we will get B or either we will get A পেলেও পপ করব, C পেলেও B পেলেও পপ করব, যতক্ষণ না কনজাম্পশন হয়ে যায়। z0 থাকলে it remains in z0 and we are reaching the final state. Now বলো দেখি, if the language is this a to the power n, b to the power m, c to the power n, d to the power m, nm is greater than equals to 1, কিভাবে ডিজাইন করবে?
ল্যাঙ্গুয়েজটা তো সিএসএল, এই ল্যাঙ্গুয়েজটা কখনোই সিএফএল হতে পারবে না, কারণ এটা অল্টারনেটিভ কম্পারিজন হচ্ছে, মানে এ টু দি পাওয়ার অফ এন, বি টু সি টু দি পাওয়ার অফ এন, তার বি টু দি পাওয়ার অফ এন, ডি টু দি পাওয়ার অফ এন, এটাতে কখনোই মানে সিএফএল হতে পারবে না।
Okay, that means this cannot be done using only one stack, right? এটাকে আমরা একটা স্ট্যাক দিয়ে করতে পারবো না, রাইট? বিকজ দ্যাট ইজ অল্টারনেটিভ। আমি কিভাবে করব? এ কে পুশ করলাম, রাইট? দেন হাউ ক্যান বি পসিবল? বি কে যদি আমি পুশ করি তাহলে সি কে কম্পেয়ার করা যাবে না। এবারে যদি বি কে পুশ না করি তাহলে ডি যখন অফার করবে তাহলে ডি এর সাথে কম্পারিজন করতে পারবো না। দ্যাট মিন that cannot be, this is not CFG, এবং cannot design machine for that, PDA ডিজাইন করা যাবে না। So this is nothing but context sensitive language, and you can design it by using linear bounded automata or all those stuff. But if the language is like that, that means a to the power n, b to the power n, c to the power m, d to the power m, that means that can be accepted by PDA. You can draw a PDA for that, or a to the power n, b to the power m, c to the power m, d to the power n, that can also be accepted by PDA, because এক্ষেত্রে কি অল্টারনেটিভ, মানে এ কে যখন পুশ করব বি কে পপ করে দেবো, আবার সি কে পুশ করব ডি কে পেলে পপ করে দেবো। এক্ষেত্রে কি এ কে যখন পুশ করব বি এলেও পুশ করব, সি এলে পপ করে দেবো এবং ডি এলে তারপর আবার পপ করব, তাহলে কন্টেন্টটা ম্যাচ করে যাবে। দ্যাট মিনস দ্যাট ইজ PDA ডিজাইন করা যাবে, that is also designed by PDA, and you can design it by using deterministic PDA, right? You can design with deterministic PDA দিয়ে তুমি কিন্তু এই জিনিসটাকে ডিজাইন করতে পারবে। দ্যাটস অল। নাও দ্য থিং ইজ দ্যাট, তাহলে বলো তো দেখি যে ইফ the language is given like that, a to the power n, b to the power 2n, n is greater than 1, তাহলে you can design it by using PDA or not? a to the power n, b to the power 2n, so whether you can design it by PDA or not?
হ্যাঁ স্যার, পিডিএ দিয়ে তো করতেই পারবো, কারণ প্রত্যেকটা এর জন্য আমি মানে দুটো করে বি এক্সেপ্ট করবো, দিয়ে তারপরে এক্সেপ্ট করে দিয়ে যখন বিটা আসছে দিয়ে ওটাকে পপ করবো সবকটা একে, যখন বি পেলাম তখন সবকটা একে পপ করে দিলাম।
আচ্ছা তুমি বলো কি করছো, তুমি যখন বলছো এ পাচ্ছ, রাইট, কি করবে?
এ পেলে দুটো একে মানে প্রত্যেকটা এর জন্য আমি দুটো একে ইনসার্ট করছি।
ওকে,
দিয়ে যখন বি পেলাম, ধরুন দুটো এ আছে, তাহলে তো চারটে পেলাম এ, ঠিক আছে?
এরকম আছে, তার দুটো এ হলো, আবার আরেকটা এ হলো, চারটে এ পাবো ইউজ হলো, রাইট?
চারটে এলে এবারে বি যখন পাবো তখন সবকটা একে মানে পপ আউট করে দিচ্ছি।
আচ্ছা, তার মানে when you are getting only one a, you are pushing 2a, right? So that means in that particular case, initially if the input is a, stack top is z naught, so you are pushing two symbols, right? That means a z naught, right? And if we are getting a and the stack top is already been a, so we are also popping two symbols, so that's why we are writing AAA. And whenever we are getting b, if the stack top is a, I am popping the thing, and that will happening, that means if the input is b, stack top is a, we are popping the thing until and unless we are getting this epsilon. If this is z naught, then it remains z naught, and this particular thing is accepted. So that is the one of the procedure. আরেকটা procedure কি হতে পারে, আর কি procedure দিয়ে করা যাবে? That means that's the one of the procedure.
ফর মানে আগে আমরা এ গুলো পুশ করলাম, যটা এ পুশ করলাম তটা বি ও পুশ করলাম, দিয়ে সবকটাকে পপ করে দিলাম।
যটা এ পুশ করলে তটা বি পপ, কি রকম একটু বলো? যদি আমার জেড নট থাকে তাহলে কি হচ্ছে, আমি ধরো এ কে পুশ করলাম, কম্পেয়ার তো করতে পারবো না, রাইট?
না মানে যটা এ পুশ করছি তটা বি ও পুশ করছি
একসাথে, তাই তো?
হ্যাঁ, তারপরে সবকটাকে পপ করে দিচ্ছি।
ওকে, তার মানে এ এর সাথে আমি একটা এ থাকলে একটা বি ও পুশ করছি, তাই তো?
সবকটাকে পপ করে একই ব্যাপার হচ্ছে ঘুরে ফিরে।
আচ্ছা, এইরকম ভাবে ভাবছো। ওকে, আরেকটা তো ভাবতে পারি যে আমি কিছু না করে ঘোরালাম, তার মানে আমি বলতে চাইছি যে ধরো if there is a and stack top is z naught, I am pushing a, right? আমি তাহলে আমি যখন stack top এ z naught আছে এবং আমার কাছে a ইনপুট এসেছে, আমি স্ট্যাকে a টা পুশ করেছি। অথবা if this is a, if I am getting a, I am pushing it, that means again I am getting a, so I am just pushing it. Now if b comes, right, if b comes, if the stack top is a, I am remains it a, right? মানে b একটা এলো, তার মানে এই b টা এলো, আমি কিন্তু স্ট্যাক টপে রেখে দিয়েছি। and the thing is that if again B is coming, and if A is there, I am epsilon. তার মানে একটা আমি স্কিপ করে আরেকটা যদি B পাই, তার মানে if we are getting the second B, I am popping this, right? So the thing is that, so again if we are getting B, if this is A, it remains an A, I can write like that, and আরেকটার জন্য skip করছি, and the thing is that if I am getting epsilon, if this is a Z naught, here remains in Z naught, and this is the final state. But of course, you know that one is a better procedure. You will take only 1 to 3 state, but in that particular case you need 1 to 3 4 states. But you can do it like that, you can do it several way, but of course what we should remember, that the number of states should be less, because in the first case, you know, the number of states that is less than the second one, so it is always been better if we follow the first procedure. Now the thing is that if we, if the language is, W C W R, right, where W is belongs to A B star. If the language is like that, W C W R, and of course W is the combinations of A and B, that means if W is equals to A B B, say W R is equals to B B A, right? And that should be done by the PDA, right? Because in that particular case, what we can say, that if we say this is a Z naught, right, and whenever you get like that, this is accepted, this particular string is accepted, because this is a W and this is a WR, and this is nothing but WR is nothing but that is the reverse of the W. So what we can say, that when, until and unless we are getting C, I am pushing the content, right? That means if this is A, we are pushing it, if this is B, we are pushing it, if this is again B, we are pushing it, right? And we are getting the content C. When we are getting the content C, what I am saying, that this particular string will be matches with this. If it is a matches, then we are popping it, we are moving it to this, and this particular string will be matches with again this. That means if after matching all those stuffs, if we reach Z naught, then that is accepted. That is the rule that will accept. That means whenever W is there, we are pushing the content into the stack. When the C, we reach at C, we are start popping it, and as well as we are checking whether the stack content will be, top of the stack content will be matching with the input or not. So what we can say, that means it may be it like that, W may be ABB, or it may be BBA also. That means it will start it with B, ending with A, whatever be that. W is a combinations of A and B. That means you should write all the conditions that are possible. That means if we write Q naught, what will happen, that means in that particular route, if this we are getting A, and if the stack content is Z naught, we are pushing it. But it may be possible the input is B and the stack content is Z naught, then we have to push this. So if after pushing A, it may be possible that another A will come. That means if the input is A, the stack content is A, we are pushing this. It may be possible that input is B, the stack content is B, then we are again pushing it, right? Or it may be this case, that means the top of the stack is A and input is B, right? Then we are also pushing it. That means the input that will coming is B, the stack top of the stack is A, then we are pushing it. Or it may be the reverse thing, that means there is B and A is come, right? That may be also the possible. That means the input is A, the stack top is B. That means input is A, stack top is B, then this is nothing but AB. So these are the all possible cases that will happen. Now until and unless we are reaching at C, right? So the thing is that it may be possible, because that is a star, right? So if there is only C is there, that is also accepted, right? Because that is a epsilon, that is a epsilon. Because AB star, that means if this is a there is no combinations, that means it is either epsilon and WR is also epsilon, so that should be accepted, right? So the thing is that when we are reaching at that particular state, that means when there is a C, the stack contain the the top of the stack, it may be Z0, right? It may be, it is accepted like that if the that C is coming and the stack top is Z0, so it remains Z0, right? It may be possible. Or C is reaching but the stack top is A, that means in that particular case C is coming, the stack top in that particular case is B, but it may be possible the stack will contain like that Z naught, B, B, A. That is also the case. That means when C is coming, stack top is A, then what we have to do? You have to remains it same. We are not popping it, we are just remains A is as A. Or if the stack top is B, that is B, but we are moving to the another state, right? And in that particular, that means I'm writing wrong, because that should be written within this, thus I'm not writing, this is not the corresponding state, the state is like that, that means this is the corresponding q1 state. And when we are reaching q1 state, that means we have to pop all the stars, right? So when you have to pop, there are also conditions, that means it may be possible that the stack top is B or the stack top is A, right? There are two possible conditions. That means if the stack top is input symbol is B and the stack top is B, then only we are popping, right? Then only the matches. That means when this is a reverse of a string. What do you mean by reverse of a string? That means if the input symbol and at the stack top that are same, then we can say that is a reverse. Otherwise, if the input symbol is A and the stack top is A, then we are getting epsilon, right? And after doing that, if the input string is empty, stack top is Z0, it remains at Z0, and that is accepted, right? So this is nothing but WCWR, that is accepted, and this is done by using deterministic. This is a deterministic by using deterministic PDA. Okay, so that can be done by using deterministic PDA. Now the thing is that, okay, that's all. That means that can be done by using deterministic PDA. So let's take an example, and please be concentrate that uh, how the non-deterministic PDA will work, right? That means because the actual behavior of a PDA is non-determinism. The actual behavior of PDA is non-deterministic in nature. That means deterministic PDA, non-deterministic, PDA. So the thing is that is the language. Say WWR. Please be concentrate. And W is given AB, plus, and this is nothing but set of even palindrome, right? Set of even palindrome, because the length of the string is always been even, right? So what we know in the previous case, when the language is WCWR, where W is belongs to whether AB star or AB plus, whatever be the thing, there is a center, right? There is a center, and so we know when to push. So when so we know when to push and when to pop, right? But here we don't have center, so we are not, because this W and WR, say this is ABA and ABA, right? This is W and this is WR. Now how can we determine that which one is center, right? How can you determine that which one is center? You may say that when we are getting a and the next symbol is also a, then that may be center. But if I am saying that a, that is also you can treat, this is a w and this is w1, so how can you determine this center, right? That means that is the case, that is possible, that you can say the two nearest symbols that are center, but in that conditions that will fail, because it may be center or may not be center. That's why the non-determinism counts, right? In that particular case, that at a particular point when the c is reached, then you have to either push or pop. But in that particular case, you don't know about the center. If you don't know about the center, that will create a problem. So that means in that particular case, but here we don't have center, we don't have center, so we are not able to know when to push and when to pop, right? That is the problem. So it has non-deterministic in nature. That means what we find in case of when we are dealing with the finite automata, that in a particular transition, that means we are in state q naught and say the input is a, so either we can go to state q naught or either we can go to state q1. That is not fixed, that is called non-determinism. So in that particular case also that will happen. So that's why that non-determinism will occur. So what the thing, if what we can say, that what should be the center? The center is that if the top of the stack and the input symbol is same, right? If top of the stack and input symbol is same, then it might be center. We don't sure about that. It might be center. I am not sure about that, because in that case, say I am pushing this a, I am pushing b, I am pushing a, and this is a z naught, and a b a, that means we are already, now this is the symbols, this is the input symbol, and this is the top of the stack. So it may be the case that top of the stack, it may be the case that when this input symbol is matches with the top of the stack, it might be a center. I am not sure, but we are not sure about it, right? But we are not sure about that. Why we are not sure about that? If we say a, right? So in that particular case, say in the stack we are pushing a, right? We are pushing already and we are at that particular symbol. So input symbol, that is a, and stack top, that is also a, but that is not the center, right? So it may be possible that will happen. So it may not be center. So that's why what I am saying, that either it may be center or either it may not be center. That means you have to consider these two cases. That means either we can go there or either it can go there. That means it is not the always that is a center, but I have to put a rule such that if this is not center, then it will not occur. If it is a center, it will occur. Let's see what we can do. How can we design this PDA? That means say we are at an initial state. So what will happen? That means the first case is if the input is a and z0 is the stack top, I am pushing this, right? and of course it may be that it will start it with B. Then if Z is not, we are pushing this, and it may be the case that we are in A and the stack top is B, right? That is not matches, then we are pushing it. Or it may be the case that B is input, A is the stack top, so we are pushing it. Now it may be the case that this is not a center, right? Means in that particular case, say this is not the center, then what will happen? You have to push it, right? Again, you have to push it again, right? So you have to consider this case. That means if A is input, stack top is A, then it may be the possible that this is not center, then we have to push it, right? But it may be the center, then what will happen? That is a non-determinism. That means these two conditions, you just look it. That means when the input is A and the stack top is A, we can pop it, right? Either we can push, either we can pop. We don't know. That's why non-determinism. That means when this condition will happen, there is a parallel computation that is possible. And at some time, if this is not the actual center, then the program will stop. You are not finding any transitions rule. We will see that. And if this is the B and the input is B, we can pop it. That is a non-determinism. You just see these two rules. That means if the input is A and the stack top is A, either it can push it or either it can pop it, right? So that will happen, and we are reaching another state. And when we are finding, let's say we are finding the center, then if this is A, input is A and stack top is A, we are popping it. Or input is B, stack top is B, we are popping it, right? And that means matching will occur, and we are reaching epsilon. The input is already consumed, and the stack top is Z naught. Then we are reaching the final state. Now what will happen? That means where is the non-determinism and how the non-determinism will work? See, that is the corresponding PDA. That is a non-deterministic PDA, right? And if we say this is the initial state, and say the say the input state, this is the initial, and say the input state, input is A, right? This is a Z naught. Now what will happen? Input is this, stack top is Z naught. This is a stack top. Then what we have to do? You have to just push it into the stack, right? We have to just push it into the stack. So we are in a QA state because we are executing this state. If A, this is Z naught, we are pushing A Z naught. So this is QS. Input is now A. I am writing like that, and A Z naught. We are pushing this A into Z naught. Now the question, because the stack top is A, and input that is also A, right? Then there is two cases can be possible. One is the no center. If it is a no center, then we are pushing it. If this is a center, we are popping it, right? Then what will happen? You just see. That means when this is a parallel path, that means there is non-determinism. Then we are in QS if A is there and the stack top is also A. One of the case it is not. If it is not treated as a center, then we are pushing it, right? So that means if we are pushing it, that means this is QS. Input consumption is less, and we are pushing it, so it is become AAZ now, right? So that is the case where this is Z naught and A, and we are again pushing A. And if it is a center, then we are executing this one. That means we are popping it, right? If we are popping it, then we are in state Q1, and A is the that is the corresponding input, and the stack top is Z naught, right? And what I am doing, this is a Z naught. That means if this is a I am just popping it, right? Now you just see in Q1 state, if we are getting A and the stack top is Z naught, there is no such configuration is written, right? So that means that is the date configurations. That is a date configurations. You cannot move through this part, right? Because no transitions rule is defined for that. No transitions rule is defined. No transitions rule is defined for that particular transition. Now you will see I am reading this A and the stack top is A. Then we are in QS state. That means it has also two cases. That means either it is no center or it may be we are reaching the center. That means if this is a no center, then what will happen? We have to push it into stack again. That means this is Z naught A, and A, that would be push. That means this is QS, input is only one is left, and the stack content is this. Either if this is a center, that means we are popping it, right? We are popping it. That means this is the corresponding stack content. A is there, so we are popping it, right? So this is a Q1 state, so we are moved to the next state. A is there and the stack content is A Z naught, right? So now again the case is that if this is a no center, that means this is the input, this is the stack content. That means that has also two cases. One is the no center and n is the center. That means the thing is that if this is no center, that means we are pushing it into the stack. That means if this is a no center, that means Z naught, this is A, this is A, this is A, right? So this is in QS, input is consumed, already consumed, and the stack content is A Z naught. And you will find you don't have any such configuration. That means we are in initial state and the input is epsilon, that is not defined in Q naught. That means that is also date configurations, right? That means that is also date configurations, because no rule is defined, right? Now if it is a center, right, if it is a center, that means the configuration is like that. If this is a Z naught, if this is center, that means this is A and this is A, right? And the thing is that this is the stack content, then what will happen? I have to pop it, right? So we are in Q1 epsilon and this is AAZ now, and we will see whether this rule is defined. That means input is epsilon and the stack content is A, and you will see that in Q1 state no such transitions rule is defined, right? That means that configuration is also date configuration. This is also date configuration because no rule is defined for that. So now we are reaching this. That means we are Q1 state. A is the this is the input symbol we are reading, and this is the stack content. That means you will see that there is a rule. That means if this is A and A, we are popping it, right? We are popping it. So that means from that particular rule, what will happen? We are in Q1 state, input is already consumed, and you are popping it. That means the stack content is Z naught, and we will get these configurations. That means if input is this, nothing, stack content is Z naught, we remains in Z naught, but we are reaching to the final state. So in that particular case, we are reaching to the final state, epsilon, that is Z naught, right? So that means that is accepted. That is if we are getting only one path, right, and that is accepted, that means the string is accepted, and all other paths you will see that will leads to a date configurations. That is the beautiful thing about non-deterministic PDA. So that means what we will see, and that cannot be accepted by deterministic PDA, mind it. That is one of the major thing. That means, so what we will see, that means this WW word, that is not accepted, that is not accepted by deterministic PDA, right? That is not accepted by. So the thing is that, so what we can say, so that means non-deterministic PDA is powerful. That non-deterministic PDA is more powerful with respect to deterministic PDA, in respect of recognition of language, in respect of recognition of language. That means we are getting a language which is WWR, that is accepted by non-deterministic PDA, but that is not accepted by deterministic PDA. So we can say that that is the case. That means when we are dealing with the finite state automata, we are seeing lots of variants of the finite state automata, but every variance has same recognition power, right? Whether it is a non-deterministic or it is a deterministic versions, what we will see that both will accept these regular languages, right? But in case of this PDA, what we will find that this non-deterministic PDA, right, this non-deterministic PDA, that non-deterministic PDA is more powerful compared to deterministic PDA in respect of recognition of language, because we find a language that is accepted by non-deterministic PDA and that is not accepted by deterministic PDA, and that is the major difference, right? And the thing is that there are some languages like L is equals to a to the power n, b to the power n, c to the power n is greater than equals to 1. Or if we write the language WW, where W is 0 1 star, that is not context free, language, and of course that cannot be recognized by PDA. PDA means non-deterministic and as well as deterministic versions, right? So that particular language cannot be, that is a non-context free, and that is a non-context free. That means that cannot be, recognized by a non-deterministic PDA. If it is not recognized by non-deterministic PDA, then of course it cannot be recognized by deterministic PDA. And for that purpose, that means this WWR, that is called non-deterministic context free language, right? You will show that when we are solving some head problems, that a non-deterministic CFL and deterministic CFL, that means the language which is accepted by deterministic PDA, that is called deterministic CFG, and if the some language which is accepted by non-deterministic PDA, that is NCFG, non-deterministic context free language. So the thing is that that is your first home task, that let's try to design this particular PDA, whether you can able to design or not. That is the language a to the power n, b to the power n, and a to the power n, b to the power 2n, right? And let's try that whether you can design it by using PDA or you cannot design it by using deterministic or non-deterministic, whatever be the thing. Let's try it, that whether you can do it or not. So the thing is that what we will
PDA তে নাল মুভ করা যাবে তো?
PDA তে নাল মুভ করা যায় তো?
আচ্ছা,
so the thing is that in that particular case তাহলে আমরা দেখলাম যে PDA টা আমার এইভাবে কাজ করছে, লাইক নন ডিটারমিনিস্টিক অথবা ডিটারমিনিস্টিক ভার্সনস যাই হোক না কেন, সেটা আমাদের এইভাবে কাজটা করছে। So now the thing is that I want to build the foundation of CFG, that CFG তো তোমরা করেছো, right? The thing is that what we know about the CFG, that is a context free grammar. The thing is that what we know that for a language, language, there may be different representations. There may be different representation of grammars. We know that. That means for a language there may be different representation of grammar. That means a language there may be different representations. There is a different representations. But a specific way to represent a grammar, that is always a good way for many purposes, because for designing a compiler or something else, it is always been better that we should represent a grammar in a specific way, right? So this CFG can be represented by two ways, right? One is called CNF and one is called GNF. By way, this is called Chomsky normal form. This is called Chomsky normal form, and this is a GNF, that is called Grayback normal form. That is a two way by which you can represent a grammar CFG. So what is a CNF? CNF is nothing but if all the productions, if all the productions are of the from A to BC or A to A, if all the productions of the from either this or either this, where this A, B and C are variables and this A is constant. That means if all the productions are of the form A to BC or A to A, where A, B and C are variables and A is constant. And then the questions and obvious, what are the advantages, right? If we write this particular CNF in this particular form, so what are the advantages? The first thing is that the length of each productions is restricted, because it's either increment by 1 or it can be remain same. That means we are giving some restrictions on the length of the string. That means length of each length of each productions, that is restricted, right? That is a restricted. That is the first advantage when we represent a CFG in CNF form. CNF is Chomsky normal form. I am just talking about this two normal form, but in your syllabus, in your GATE syllabus or whatever, but there are lots of normal form, right? It is not only Chomsky and Grayback. There are lots of normal forms are there, and that is particular, but that is not included in your as well as GATE syllabus as well as semester syllabus. And the thing is that the derivation tree or the parse tree, derivation tree or parse tree, that is obtained from this CNF is always binary tree. That means the length of each production, that is restricted, and derivation tree or the parse tree that is obtained from CNF is always binary tree. That means only there is only the children is either 2, because A, from A we are generating BC or we are generating A. That means it is a binary tree, right? And the thing is that the number of steps, the number of steps, the number of steps that required to derive a string of this length w is 2w minus 1. This is the number of steps required to derive a string of length w is 2w minus 1. How can be possible? If the question is how can be possible, you just see that if the productions is in that particular form AB if A to A and B to B, right? So now say we want to derive the string, say want to derive a string AB, right? I want to derive a string AB. Then what we can say about that? That means from first productions it is AB, then in second productions AB, in third productions AB. That means three steps are required, right? Three steps are required. So what I am saying, in that particular case the length of the string is 2. So what I am saying, the number of steps is 2 length of the string minus 1. That means 2 multiplied by 2 minus 1, you just see it will take 3 steps, right? So you can restrict the number of steps for that. So the thing is that how can we get that? That means when we want to derive a string, we start from root, and in every step the number of variables are increased by 1, because either you can replace it by AB, that means if this is a variable or non-terminal, that is increased by 1, and which means the string length is increased by 1, or the number of terminals that are increased by 1, right? And to the number of steps that is required to generate the string length of W, that is W minus 1. If we now replacing the string with the terminals, that will take 2W minus 1. You just remember the thing. I think the examples, from the example it is clear that what I want to say now. So what I am saying, there is an algorithm that is called, so what I am saying, it is easy to apply. This is an algorithm that is called CYK membership algorithm. CYK membership algorithm. If we remember the 2 or 3 class previous, I am saying that if a string is given and you have to check whether the string will matches with this, it will take polynomial time algorithm, right? It will not polynomial, exponential time algorithm that we will face. So the thing is that we will face, if we just a minute, I am showing you. So in some previous class we already described that is a complexity that is exponential complexity, right? Order of p to the power 2w minus 1. And what we actually want to find, if you see the initial way, that what I want to find there, that means given a string w and given a grammar, you have to generate a language, and now you have to say whether this particular strings is belongs to this language or not, right? So that can be done by a brute force method, and the complexity that we will find, that is order of 2 to the power w minus 1, and that is nothing but exponential complexity. And of course that is very exponential complexity, that will be the worst thing that we can think of. So the thing is that there is an algorithm that is called CYK membership algorithm. Okay, that means what is the CYK membership algorithm? That means given a grammar, and given a string, we want to know whether string can be derived the grammar or not. Derived from the grammar or not. That means we are given a grammar and a string is given. That means whether this particular string belongs to this language, or means that particular string is generated by the grammar G. That is the same as that CYK membership algorithm. But what is the beautifulness of CYK algorithm? That when you have to implement this CYK algorithm, that means you have to first convert the grammar into this particular format, right? This particular format is nothing but CNF format. And if you can convert the grammar into CNF format, then only you can apply CYK membership algorithm. And of course this is a universal, this is a universal algorithm, this is a universal algorithm. And the complexity, that is a polynomial time algorithm, this is a polynomial time algorithm, this is a polynomial time algorithm. That, and of course they can parse, that means they can parse every grammar, they can parse every grammar. And but in compilers there are many parsing algorithm, right? When you are dealing with the compiler, you will find there are many parsing algorithm which takes linear time, but they cannot parse all grammar. It may be possible that someone asks you a question, okay, so that's why that is a universal algorithm, that's why we are applying it, and that will get polynomial time algorithm. But but in compiler, when you will study the subject compilers, you will see that there are many parsing algorithm are there. There are many parsing algorithm. There are many parsing algorithm which takes linear time, which takes linear time. But they also, they cannot parse all grammars, they cannot parse all grammar. And most powerful, this most powerful algo, this is a CLR parser, right? That also cannot parse all grammars, and that is the beautifulness of CYK algorithm. That means CYK algorithm can parse all the grammar, and that is the universal algorithm. It may be possible there are some linear parsers are available, but the thing is that that is not universal. That is not universal. So now the thing is that if the grammar is, that means in some questions in your markout, it is given that you have to convert the following grammar, you have to convert the following grammar into CNF form. What is the full form of CNF? That means this is a Chomsky normal form. Let the grammar is it is given like that, the grammar is given like that, say and A B B B S B. That means this is nothing but the language that is generated by the grammar. Its number of A's that should be equal to number of B's. So now this is not the standard way, okay? This is not the standard way, because when you are writing this CNF, that has two rules. That means every productions rule should be written either this format or this format. This is the two format by which you can express the all the productions rules of the grammar, then it is a CNF format. So this is not a standard way, so you can add any number of productions or any number of variables. So the thing is that in case of step, we can say adding first new variables, adding new variables, and it is very easy to do that. That means adding new variables, that means don't substitute directly, right? Don't substitute directly. That means I am writing say NA to A, this is the one of the productions, and NB to B. I am just introducing this production. If we can introducing this production, so because that is not in CNF, so BA, so what we can write NBA, and of course that is in CNF. This is the NAB, that is also in CNF. From A, that is NBAA, but that is not in CNF. This NAS, A is also in CNF because A to A, or B, this is NA, BB, NBS, and B. We are just replacing this like that. So now if we can replace it, what we can find from that, that is its CNF, that is also CNF, because the CNF form is either A to BC or either A to A. So if this is a this is also variables, this is also variable, that means that both are non-terminal. So this is in CNF, this is in CNF. A to A, this is in CNF, this is in CNF, this is in CNF. What is not in CNF? This is not CNF, and this is also not in CNF. So what we can say, you can take any one, right? That means you can take, say, this AA can be taken. This AA can be taken with another variable. This BB can be taken with another variable. Say this can be taken with this can be taken as P. I can take it like that, and this say Q. Then what we can write from S? This is a NBA, NAB, no problem. There are from A, I am taking, this is NB, P. I am taking as a P, and this is, and from B I am taking BB as a Q. This is NBS and B, and this is NA to A, NB to B, and as well as P to AA, and Q to B. So this is nothing but we are writing the grammar in CNF format. That means each and every productions that are in CNF. That is a CNF. So I think that part is clear or not.